One of the central questions in dream science concerns the origin of the experience. Does a dream emerge because a dominant emotional memory already exists before sleep, or is that organization gradually constructed during the dream itself? Top-down models argue the former, that the governing emotion exists before dreaming, and the scenes we see merely uncover different branches of a latent emotional hierarchy. Bottom-up models suggest that initially, only small, independent emotional packages exist, which then self-organize into a dominant field through cortical interaction during sleep. The Brain Kinematics Model, or BKM, suggests that neither a predetermined script nor random neural events can fully account for the complexity of dream evolution. BKM frames this as a problem of self-organization, applying the principles of complex physical systems and far from equilibrium thermodynamics to the brain's internal environment. Waking experiences do not simply disappear after perception ends. They leave behind residual strain within cortical networks, distributed packages of tension defined by their emotional intensity and conceptual complexity. When these interacting strain fields reach a specific level of organization and coherence, they cross a conscious threshold. This threshold crossing represents a phase transition between unconscious cortical dynamics and conscious imagery. Much of contemporary neuroscience associates conscious dream experience with transient coordination among neural populations, primarily focusing on isolated regional activity. BKM extends this by proposing that the underlying organizing variable is the evolution of distributed cortical strain fields. It tracks the amplitude, coherence, and persistence of these fields across the entire cortex. This leads to the hybrid dynamic trade-off model. In this framework, the dream evolves through the continuous interaction between pre-existing emotional potentials and the real-time self-organization that occurs during REM sleep. Under this model, the dream is an observable trajectory through the physical landscape of the brain, mapping how unresolved waking tension becomes an integrated narrative. To understand how these trajectories form, we have to view the brain as a multidimensional strain space. This phase space allows us to plot mental events based on their amplitude, dynamical frequency, and persistence. The present sensory field is driven by external perception. It is characterized by high-frequency dynamics and a rapid rate of change. The residual strain field carries recent unresolved experiences, which possess intermediate dynamics and exert a strong emotional influence on the system. Long-term memory occupies the lowest activation frequency but remains highly persistent, providing the stable, consolidated knowledge of the system. These fields are not discrete compartments. They exist as overlapping probability clouds within a continuous manifold. Where these clouds intersect, they form cloudy transition zones where information is continuously exchanged and transformed. Dream emergence preferentially occurs within these active overlap regions rather than at the stable center of any single field. As distributed cortical strain reaches a level of organization capable of supporting imagery, it crosses a conscious threshold, forcing the system into a stable attractor. Because of these continuous overlap regions, the transition into sleep is a smooth trajectory through the phase space, rather than a sudden break in consciousness. This continuity helps resolve the incubation paradox, the question of how an intentional thought repeated just before sleep can dominate a dream that usually relies on much older residual strain. Pre-sleep incubation forms a bridge state between active waking perception and the onset of dreaming. This semi-present temporal field possesses high temporal proximity and high internal coherence. An incubated thought remains dynamically active. It retains the coherence of waking attention while facing minimal competition from external sensory inputs as the body transitions toward sleep. This unique positioning allows the incubated thought to bias the earliest attractors that emerge during REM sleep. BKM classifies this as transitional strain, a still active deformation that crosses the sleep boundary continuously, distinguishing it from completed residual memories. Rather than overriding the emotional landscape, incubation acts as a seed crystal in the transition zone, influencing which attractor becomes conscious first. To ground this theoretical physics in psychological reality, we can analyze the four-stage progression of a single dream sequence. Initially, the dreamer's cortex contains several partially independent strain packages, each representing a different emotional or conceptual tension from their waking life. Stage 1 introduces an approaching enemy. Because the threat is abstract and indirect, it represents the activation of external uncertainty, an anticipated stressor without a concrete object. In stage 2, a couple entrusts their baby to the dreamer. This activates the responsibility node, symbolizing something vulnerable or an idea that cannot yet protect itself. Stage 3 sees the baby grow sharp, frightening teeth. This represents the ambivalence and danger node, as the brain updates its prediction from a dependent infant to an entity of unexpected strength. In stage 4, the dreamer organizes protection inside a glass room. This represents boundary management, the attempt to preserve a protective cognitive space while maintaining visibility to the outside. From the perspective of BKM, these 4 disparate strain packages are being pulled together into a single dynamic scenario. The emerging point of the dream occurs the moment these packages reach sufficient spatial coherence to produce a single conscious image. The dream narrative is the cognitive result of the brain attempting to synthesize multiple interacting structural deformations into a coherent sequence. The turning point occurs with the baby's exaggerated teeth, a moment of intense fear and uncertainty. This chart tracks how those independent emotional branches progressively merge into a single field during the dream's evolution. The climax point represents the highest level of organization reached by the evolving dream. This is the governing emotional umbrella. It marks the moment of maximum cortical integration and synchronization across the entire network. Once this integration is reached, the dream resolves. As the dreamer recognizes the baby's intent and organizes the house, the integrated strain field is progressively reduced. This successful progression from unstable dynamics toward a regulated configuration demonstrates the brain's ability to rehearse adaptive regulation and reduce internal strain. Viewing the dream process across these temporal fields shows us a system in constant fluid motion. We can trace the path of a single thought as it transforms from active sensation through the bridge of incubation into the deep landscape of residual strain and memory. The emerging dream point and sleep transition are connected by continuous evolution. Under BKM, dreams map a landscape of pre-existing residual strain while actively constructing an emotional climax through real-time self-organization. This reveals that the underlying strain distributions form a continuous manifold, where perception, dreaming, and memory are different regions of a single probability space. Dreaming manifests as a mechanical evolution of cortical strain, existing as one point on the continuous and unbroken spectrum of consciousness.